Well, good morning, everybody. I'm going to start off first with the newest drought monitor map. So this was released yesterday on Thursday. And what it's looking at here is across the lower 48, we've got about 60% of the land area in some form of drought, from abnormally dry all the way up to exceptional drought. If you want to just classify only the drought categories by dropping off the abnormally dry category, then we're looking at about 40% coverage here. And some of the questions I've been getting asked a lot about is what's changed and how does it compare to last year? So let's go have a look at that real quick. Remember, on this website, come over to Maps, hover over that, and come down to Change Maps. And then you can see the drought monitor and how much it's changed. So this is the last week, how much we've seen degradation in parts of the Mid-South, getting into the Southeast, pockets throughout the Ohio River Valley. There's been a few locations where there has been some improvement in the drought monitor, but maybe it's a bit easier to see this over a longer time period so we can stretch it out to a month. And that'll really start to show you some of the bigger issues we've seen. So throughout the Ohio Valley, the Tennessee Valley, down here into the Southeast, along the lower Mississippi River Valley has been kind of our largest area of drought expansion just in the last couple of weeks here. But like I said, there's been the question, how does this compare to a year ago? So let's go have a quick look at this. Another great tool they have here is a slide comparison. So what I can do here is I can show you the current drought monitor, which is this one, and I'm going to compare it to 1 year ago right now. So if you're curious, this is what things looked like last year at this time in October. So we had substantial drought throughout the West. Of course, this was knocked out mainly in January and again in March with two series of massive storm systems that hit the western United States that pulled it out of drought. But we did see a bit of expansion to the east of the drought monitor from a year ago. So this is a year ago and this is now. So you can see it's moved kind of into this corridor and moved here as well. So we're going to ask the same questions. What can fall do to undo this drought or start to undo it? And then is there kind of a better hope for spring going forward with this? Another way to look at this, though, since we're doing this comparison, is I want to show you the latest soil moisture values from NASA. This is looking at the 100 centimeter or 40-inch soil moisture values currently. And I keep an archive of this. They do as well, but I want to show you what it looked like a year ago. So this was on October 6th last year. Now, I would like to make the point that more of the Missouri Basin. So remember, the Missouri River comes in like this and sneaks down and just right near St. Louis before it dumps into the Mississippi. More of the Missouri Basin was drier a year ago at this point. And if we look now, we have some of it, but a lot of this kind of region right in through here, what feeds into the Ohio, what feeds into the Great Lakes, and then what gets into the lower Mississippi River Valley has got extremely low values. And that's why we continue to monitor this, just given the similarities between this year and last year. From there, though, I do want to show you the last 30 days of precipitation. So this just kind of echoes where we've seen that drought expansion. So a lot of it's been here, parts of the eastern Great Lakes and Ohio River Valley. This has been an area that struggled for moisture all year long. We have yet to see the start of the wet season into California, which is why it looks like that. And there are just, again, like we talked about yesterday, just several locations that have continued to miss out on key rains over the last, not just month, but in some cases, several months. So with that kind of as a backdrop, let's look at the last 48 hours of total accumulated precipitation. So this, again, just last 2 days with that first of two systems. Remember, we had the low that came out earlier this week here. It's now moved into Ontario. It left that lingering, slow-moving frontal boundary. The second wave, the second cold front is diving in right now. That's the one that's delivering the colder air and a little bit more precipitation behind it. We're going to watch that continue to slide through the country as we go forward. But where this is all going to meet up and hang out for a long time, and you'll see this in a few minutes, it's going to be right over this area. We're going to watch a low just sit and spin here for several days while much of the rest of the country goes over drier. Okay, with that, just as a very quick backdrop, I want to talk to you about bigger picture things. Let's talk about this new long-range forecast just released by the European model. Now, before I kind of get you there, I want to set you up with this. If October to December, we're going to behave similarly to El Nino events that we've seen since the 60s. I'm just going to look back to the 60s, okay? For October to December, focusing only on precipitation here initially, we would expect there to be a couple of wet corridors. California, this section of the country, and then along the Gulf Coast up to the East Coast. It tends to be a little drier around the Ohio River Valley and drier than normal in the Pacific Northwest. And again, I've drawn this for you a few times, but this is primarily due to split jet stream flow that comes in like this or rides along the southern United States like that. So we have two pieces, the polar branch and the subtropical branch. That would be kind of what we would typically get if we were going to have an El Nino. But we've been raising this question as to how El Nino-like according to history, this current El Nino is. And so I want to show you another piece to this. Sorry, this map's kind of small when we look at it first, but what you've got here is a correlation map against precipitation for October to December. And we're going to correlate this with Nino region 3.4, Central Equatorial Pacific Ocean temperatures. Where we see the warmer colors, these means historically wetter. This would mean historically drier. So you can see the drier risk here, but those wetter corridors, as we just talked about, possibly a little bit, drier right in through this area. So there are some similarities when you just make a composite of the previous images, or you do a correlation with precipitation, which is what we just did here. So in other words, if El Nino is going to be our dominant global teleconnection, this is what we would expect. So I want to kind of make a case for why I don't expect this, and then leave in the caveat though that should El Nino grab hold of this pattern, expect this. Got it? So we kind of have two different views as to where this could possibly go moving forward. So here's the things we need to be discussing. Our El Nino continues to grow. We've made an argument that it's more of an east-based El Nino setup. We've been watching the colder ocean temperatures here, which are influencing the Pacific jet stream, and we still have this colder water tucked away right into this area. It is quite warm in the North Atlantic, quite warm in the North Pacific as well. But these are the three components of the ocean temperature, which are kind of the symptoms telling me what the winds are doing in the low levels, which ultimately affect where the convection is, which ultimately affects where the flow is in the upper levels of the atmosphere. It's all a thermally driven setup here, right? So it's all about the movement of heat setting up the contrast, which drives the pressure gradient, which drives the wind, right? So these are the things we're watching when we give you these other forecasts. Now, as I look at all of this, the other piece of this that has to be discussed, besides these three components, the warmth here, the warmth there, is what's going on in the Indian Ocean. We've mentioned it a few times, but I want to make a case for the Indian Ocean and what it's currently doing as being, I jokingly told some colleagues yesterday, I think it's the most well-behaved teleconnection I've got for you right now. So this is what I mean. What's El Nino up to? Well, we have watched since summer El Nino grab about 0.2 of a degree of warming in Nino region 3.4. So this has not been the super accelerated warming that we would need to get into that super Nino status. Now, this is based off of the CDAS data set, and so this is actually a part of our numerical weather prediction initialization scheme. But what you've got here, it's 1.1 degrees above average. Now, why do I say that? Well, this is the newest update from the European model. Came out yesterday, just after I recorded for you. And their projections are now taking this somewhere up to around 2 degrees above average, and then dropping it back off once we get past the middle of winter, so December, January. That's very common. That's when El Ninos typically peak. So, if we're sitting somewhere in this vicinity, what I'd like to make a case about is over prediction. So I'm going to take you back, and we're going to look at the data that was released, how about back in July? So the forecasts in July were to take this very quickly, up into some range like this. That dotted line is what actually happened. So no matter how far back you kind of look, we can just go back to the August forecast. We can then go to the September forecast. The models continually over-predict where this thing is going to go. So it's not going to be, it's strong. Don't get me wrong there. It is a strong El Nino and will influence the pattern. But it is not as strong as some of the forecasts have been indicating. And we've been looking a lot at what the Bureau of Meteorology has been saying. And I told you multiple times, I trust the Bureau of Meteorology's analysis because Australia is typically, it's Australia and Peru, right? Those two locations are on the most direct kind of receiving end of an El Nino or a La Nina event. And so when we see that their forecasts are so aggressive, and they continue to be, they're looking at 2.8 up to 3 degrees C above average by January. And we know some other models are below that. It begs a question as to why the over predictions are happening, and is there any chance of this actually occurring? And with time, as I start to see the forecast trend, my suspicions are that other things are going to dominate this pattern. And I want to talk to you about them for a moment here, okay? So we bring this up every once in a while, but I want to explain to you another global teleconnection that in some years I don't talk too much about. In fact, I haven't talked too much about it since 2019. And I don't imagine a lot of you remember my videos back in 2019 or when I started way back in 2013 doing this stuff. But right in through here, since 2020, we've watched the Indian Ocean dipole stay either near normal or dip negative. And where is it now? It's coming way back up here to where it was back in 2019. And that's got a lot of folks in Australia very worried, because as that event unfolded in 2019, this was what sparked these massive heat waves across Australia. In fact, there was a day, what was it? I believe it was December 18th, 2019, where the average temperature for the entirety of Australia, everything, was 107 Fahrenheit. They had brush fires in the southeast, and so we worry about a pattern like this. Now, what is the Indian Ocean dipole? Well, I think you're pretty familiar with how El Nino and La Nina work. I'll explain it again in a few seconds, but here's the Indian Ocean dipole. I love these diagrams. They're from the Bureau of Meteorology. I used to use them in my courses when I taught at the University of Illinois. And what you've got is what we call the neutral phase. So if we kind of click on this, there we go. When things are kind of running normal, you have this circulation that goes like this across the Indian Ocean. Okay, you can kind of see how it fills out like this. And therefore, when things are normal, it's very wet around Malaysia, Indonesia, the Philippines, Northern Australia. This is where it tends to be wet. Okay, what happens when the Indian Ocean dipole goes negative, which is what it's been doing? When the Indian Ocean dipole is negative, we tend to take that same circulation and enhance it a bit. And it does a lot of that. So we tend to get a lot of warm water here, cooler water there, and increased rising motion, again, over Indonesia and Australia. For 3 years, we've seen this, and it was accompanied by a La Nina, which enhances this. Now, what does all this mean? Remember, these indices, like El Nino and like the Indian Ocean dipole, are really just telling us where this is going to be. And another way by which we look where that's going to be is the MJO, the Madden-Julian oscillation, right? So every single thing I keep telling you about, they're all the same. It's just different ways of looking at it. So this means a whole lot of MJO phase 5, phase 4, maybe even out here in phase 6, whatever. This is subsidence in MJO phase 1. And there's actually going to be subsidence way over here in MJO phase 8. But that's when there's a lot of rising motion here. Now, I need you to tuck those numbers away in the back of your head for a few moments. That's the negative Indian Ocean dipole. This is what happens when you have the positive. So when we're in the positive phase, we now see very strong winds that come across the Indian Ocean. The rising motion is over here in phase 1, and there's sinking motion in phase 5. And that produces drier conditions, and a bunch of cool water begins to show up right in through there. Now you've seen this. Where did I put that? There we go. See all the cool water showing up here? This is an indication of this Indian Ocean dipole going very positive again. So we're about to enter a time period where this is going to dominate. And I think right now, compared to all other global teleconnections that we use in early fall, this is maybe the most important one. Now, later in October, we'll be talking about Siberian snow cover. We'll be talking about pressure patterns across the North Atlantic, the Arctic, the Chukchi Sea, what's going on in the Bering Sea. That's all coming up. We're going to get to that. Sea ice, all of that. That is all a major component later in the flow. But right now, I still think the tropics have a control on the pattern. Now, let me do the same explanation for El Nino, just in case anybody watching has never seen it. And for those of you that have, here's a quick refresher. Normal, neutral, the Walker cell, okay, named after Sir Gilbert Walker. Trade winds blow in this direction, a lot of rising motion here, sinking motion there. Now, remember, when everything's normal, and you also have normal Indian Ocean dipole, do you remember what it does? You get rising motion here that comes across the Indian Ocean and sinks over by Africa and comes back like this. That's why parts of the Horn of Africa are normally desert, right? Okay, so that's normal. I put the IOD on it, and I put the Walker cell on it, which is neutral INSO. Okay, what happens when there is a La Nina? Okay, so when there's a La Nina, this whole thing is just cranked. I mean, it's moving fast. And we saw that for 3 years. And that's what spread a lot of rainfall into parts of Southeast Asia, Indonesia, Malaysia, Philippines, and then down into Australia as well. Okay, we saw this for 3 straight years. The question is, are we actually going to get into this dominating? Now, can you see what's going on here? Watch. At the same time, we have positive INSO, which is El Nino. We have positive IOD, meaning there is sinking motion here. Flow is coming across, rising over Africa, and going back. So what does this mean? We have a lot of sinking motion in phase 5, rising motion in phase 1, and in phase 8. And what that does is that's the redistribution of rising and sinking motion. This is where the production of clouds are, here and here. So that redistributes where the heat is exhausted into the upper levels of the atmosphere, which changes the pressure gradient because it changes the temperature, and that alters the position of the jet stream. And it's just one component. I could tell you about a dozen other global teleconnections that can do something, but we're wondering if these are going to be the most dominant. So this is what we're currently in right now. This is the positive phase of INSO. All right, take a look. This is how I actually view all of this. This is today, and we're going through the next 15 days. And you see the blue-greens in here? That indicates strong trade winds going in this direction. See these colors? That represents winds like this. See the reds here? They're going like that. And you can see a little blue over here. They're doing this. So what does this all mean? Where the arrows come together, air is rising. Where the arrows part, air is sinking. So see that? That right there tells me where the MJO is going to be. It's not going to be in phase 5, 6. It's going to be out here, either out in the middle of the Pacific or over phase 1. Now, the other way by which we look at this to complete this story is I can actually look for rising motion. And here it is. Right now, this shade of color for the next 15 days, almost straight up and down in the diagram, is sinking motion here. The blue-green is rising motion. The blue-green, rising motion. So see that now? That's about looking at horizontal first, vertical second. This means the MJO is not phase 4, 5, 6, but probably phase 1 or phase 8. So it's somewhere here or here. Now what's important about that is we can just go out and look at a phase diagram to tell me where it is. And we see that it's somewhere over here in the Western Hemisphere, or it's in Africa. And that's where I'm going to be watching for it. I think it's mostly Africa right there. Now, phase diagrams, the farther you get away from the center, the bigger the influence. And we're outside of the null space circle, and we're sitting here. All right, here's my point. If the MJO, which is moving on top of the Indian Ocean Dipole and El Nino, favors phase 1, and let's say that it continues to favor phase 1 because El Nino and the Indian Ocean Dipole work together, with the Indian Ocean Dipole being the more dominant force keeping the MJO in this area, that historically correlates in October to western U.S. troughs. And so the flow pattern does something like this. And we tend to get blocking high pressure over the Northeast, over eastern Canada. Now, if this happens, and we get here, then we expect between the trough here and the ridge there for the pattern to be very stormy in this area. So if the MJO stays in phase 1 and we get a true teleconnection out of it, enhanced by the IOD, enhanced by El Nino, this would be the kind of beginning of the end of the drought in the midsection of the country. What's missing? If you took that ridge and put it down here, then I'd tell you the drought is over. It'll expand in the southeast, but be over in the midsection of the country. But it's not. It's up here in this part of Canada, which is why it's not the perfect scenario. But let's just say that's what October is going to favor, more western troughs. So what does this mean for the west? This actually means a cooler start, more snow early. This could mean better systems that roll into the Pacific Northwest, that roll into California. And this also means that these dry forecasts for the west, are likely not going to verify, especially as we go from October into November. Now, if this is what November looks like, look out. I mean, this is just screaming systems in through here. This is not at all a dry signal for the Pacific Northwest. This brings moisture into Northern California. And look where the ridge went. It went right out here. Now, if that ridge goes out there and flow comes around it, that is the type of setup that helps take these systems and screams them up, into this direction, into this high. So this also is a Midwest setup. This is also possibly helping out the East, all depending on where this goes, helping out the East with storm systems in the month of November. And if we just keep the MJO over there, and it's still there in December as these two things, the IOD and the the IOD and El Nino work together, it looks something like this by the time we get into December. And by December, deep Gulf of Alaska troughs send systems right around into the West Coast, helping work against drought risk in the Northwest. Screaming subtropical jet. This pushes through the Southeast. And a ridge of high pressure here in December is typically a colder feature, not a warmer. And, we end up getting flow like this around that ridge. So I'm just telling you that all these long-range forecasts that are just very anchored into El Nino, it is always more complicated than just one thing. But it's easy just to give you the soundbite that says, oh, El Nino winter, here's what you expect. It's reality of it is quite nuanced and complicated. So that's going to be what I think is going to happen. I don't think El Nino is necessarily going to, I think El Nino is going to have a buddy called the Indian Ocean Dipole, and his buddy's going to dominate the pattern, at least in the beginning, until those, Arctic features start to take over. Then we have a whole nother story to talk about. So if you feel as though you have an idea about what this winter is going to look like, I would just say proceed with caution, because I don't think it's going to look like what the simple answer is. So what's the simple answer? The simple answer was just given to us by the European model. This is what they've got for October ocean temperatures, November, December. Continues to be more of an east-based setup on El Nino. We still have cooler water with the negative PDO here. We've got the Indian Ocean Dipole going, and we'll be watching through December what happens in the Arctic. That'll be another main piece to this. So what does all this mean? If we come in here, let's just take a quick look at the United States. And we look at let's do the seasonal precipitation anomalies. This is what, let's go back. This is what October, November, December is expected to look like. Now, to be honest, the model went pretty aggressive on precipitation for most of North America. And if you drop a big West Coast trough into here, sure, that's what you'll get. It'll be active across the whole country. So there is something to this overall. But as we go forward, the models November, December, January are keeping the Southeast very wet. They're keeping the Midwest wet, but they've dried out the West Coast. And I look at that and go, okay, how are you going to dry out the West Coast if we keep the momentum going across the Northern Pacific? I don't understand why it went so dry. And it's still dry December, January, February. And as we look out there, this December, January, February, this is still very El Nino-y. We tend to be drier in parts of the Ohio Valley, drier in the Northwest, but not drier in California. It tends to be wet from here to here to here with a little bit of a wet shot right in the middle there. That's typical El Nino setup. One thing I did note is we'd break this out to a North American view, okay? And I show you the upper air height pattern. Let's just do monthly here. This is what the models are going after for December. Now, doesn't that look familiar? Doesn't that deeper western trough look like MJO phase 1? So we have to watch out for MJO phase 1. It's starting to show up hints in the longer range forecast, and I think that's going to be critical to watch. Let's go ahead and come back to just our U.S. view, and I want to show you now the temperature pattern. Now, there is a warm bias in this, but that's the December temperature bias. Getting into January, if it'll go, there we go, January and February. The European model just came out much, much colder than had previously been forecast. And if we stitch those 3 months together, this is what the new forecast looks like. So the discussion about typical El Niños being very mild to the north and cooler south, some of the new data are suggesting otherwise. There's still too much of an El Nino only flavor, in my opinion, in the European model. That's why I mentioned that a moment ago. But that's the newest update we got from the model. It's more aggressive. It's putting out there a bit more of an interesting winter overall. And maybe it's capturing better the Indian Ocean Dipole effects. Maybe that's what it's seeing here. But that's kind of the newest update we've got for the U.S. Okay? Now, throughout the next week, I'll talk about other regions around the world. But for now, I'm halfway through my slides, and we've been at this video for a while. So let's kind of get into some other things going on right now. We have seen a bit of an uptake in global momentum. So what we're going to be watching for this is what's the North Pacific going to be doing in terms of jet stream activity. We look at the phase diagram for that. We're seeing the jet stream make a bit more of a poleward shift, and it's starting to extend a bit. So it came from here and is now starting to move a bit farther to the north and get over on this side of the diagram. So what does that mean? Instead of having a southerly jet that's weak, we're starting to see more of a stronger polar jet racing across the North Pacific Ocean. It looks something like this right now. So as we play through this weekend, here's the deep trough of colder air diving in, supported by the subtropical jet to its south. We then work our way into Sunday and Monday. As we get out there to next Tuesday and Wednesday, this will be the main thing we're going to watch. The extended Pacific jet, look at this, is going to dive a trough into the west right here. And it's going to open up out ahead of it some warmth and a low pressure center that's going to come out here and go across the central United States. Could be one that produces some severe weather. Again, that's next Wednesday into Thursday right there. But after that, as we get out there past Friday the 13th into Saturday, Sunday, and Monday, we start to see the longer range models configuring the jet stream something like this. And what did we lose? We lost that subtropical component that was here. It's now just stronger in this area, but we have an extended Pacific jet stream on the northern side. So that's the setup going out there. And if you're curious, how does this compare, since this is mid-October, this is October the 19th, how does this compare to, normal? Well, this is what normal would look like. Whoa, let's shrink that up for you. Normal jet stream pattern in October, when you combine 1970 to 2022, does have a bit of a stronger piece coming off of Asia, trying to get over here, but there tends to be a better subtropical component there feeding into the United States. So we're not too far off of our climatological averages here. I would just make the case that the jet is more extended and there's a weaker subtropical component to this. So what does all that mean? Well, as we kind of play this forward, oops, we saw that, it means I would expect a bit more volatile temperature pattern. We've already watched the temperatures drop behind the first front, which is here. The second front, which is coming in behind it, is adding another 20 degree or so drop in temperature behind this thing. And we know that that area currently, as of 5:30 this morning when I'm recording, we have widespread freeze watches and warnings. We have frost watches out for all of this, and a frost advisory that extends all the way down into southwestern Missouri. Just on the other side of that, we have dense fog in through here early this morning, and also in this part of Virginia. And there's a red flag warning that's out for parts of Louisiana, Mississippi, and Alabama. So taking a look at what the temperatures are up to early this morning, we're well below freezing here, and we're going to watch this colder air advance over the next couple of days, because this is what the wind field's going to look like by this afternoon. So that front is advancing very quickly. You can see the flow. It'll be right in through here by this afternoon. And at that point, our attention is going to turn to how far that cold air gets to the south. Then what happens with Lydia. There's an interesting story on Lydia coming up. And what happens here with Philippe. So let's get into this near-term forecast now. Okay, frost advisory. This is what the newest update looks like. So now you can start to see what we discussed all week, the patchy frost starting to fill itself in this area. And now you can see where the broader area is expected to be of those temperatures down there below freezing. We then say on the precip side, is there anything coming in with that front? And there is. There's some scattered showers throughout the day today here. Again, this is the second front. The first one's curling up right over the Appalachian Mountains into New England, and it's all going to culminate in a deeper low right here. So as we play through Friday into Friday night, getting our way out to Saturday morning, Saturday midday, getting into Saturday evening, we see a couple of things. Potentially very heavy rainfall right in through here on Saturday. This is hitting the same region that a week ago was flooding. And then we watch Philippe right here move its way into, as a post-tropical storm, into Maine. And that's going to combine and sit and spin over this area for a while. And while that all occurs, here's some of the precipitation shield coming off of Lydia. That's going to be interesting to watch get over into the Gulf. So right now, Tropical Storm Philippe is expected to transition to a post-tropical storm, develop a bit of a colder core, and move toward Maine by the time we get into Sunday, and again wrap up into that low we're expecting to form here. On the other side of the U.S. and Mexico, we've got Lydia. Now, we've watched Lydia in the forecast models be predicted to make this turn, combined with whatever's out here with this 80% probability of developing area. And our question is, how is this going to get into Mexico and then eventually into the Bay of Campeche? So the chances of tropical depression development are still up there, 50 to 80%. And whatever comes out of this is being forecast to move off in this direction. To show you that, I think it's best to look at our two models together again. So we have the GFS left and the European right. As we play this forward, we've already watched through the beginning of this. And so this is now on Sunday evening. So that's where the lows, multiple, are all curled up here. We do have the risk of snow in Ontario and into Quebec. Now notice our tropical activity down here. It's in both models and the next coastal low coming into the northwest. So into Monday midday, into Tuesday afternoon and evening, we still have the cutoff low still spinning here. So pesky clouds, rain with some embedded snow, as you can see in the GFS. And then a much deeper low comes into the northwest Monday night into Tuesday. And now you can start to see it. There's not so much cold air that we're seeing the models pick up a lot of snow out of this one, but it's certainly going to be providing some decent precipitation. Now, playing this through Wednesday morning, Wednesday afternoon and evening, we notice that Lydia is coming in here. There it is in the GFS. And we've got some kind of pulse of tropical thunderstorm activity racing toward Florida. The European's going to get it there first. But behind all of this, remember we have the longer wave coming in and trying to eject a storm system in the midsection of the country next Wednesday. We've been talking about it all week. This is now where the latest model runs are projecting that system to go. The GFS, being more progressive, pushes it farther to the east, so we're going to keep an eye on this frontal boundary next Wednesday, Thursday, Friday as it progresses across the country for the risk of stronger storms. The European leaves it out here for longer, sitting on a frontal boundary in through this area. There's the the cold front to the south of this. So the European's slower in evolving the system. So by next Friday, the GFS has already got it lined up with the East Coast. The European's still letting it hang out in the Ohio River Valley with heavier showers and storms down here along the Gulf Coast. Again, prompted by what's left of Lydia. So that kind of gets us out there pretty far in the forecast to compare the models. Let's just go out a week. This is what the GFS, no. This is a European, forgive me, says out 7 days. And we can compare that to the GFS. So there are some important differences, especially right in through here. In fact, let's just go do this real quick. What do I call that? ECMWF comparison. There it is. So this is the difference in the models through 7 days. Wherever you see these colors, European is wetter. This is where the GFS is wetter. So right in through there, much wetter in the European. GFS is wetter to the north. GFS is also wetter down here. So a few different things just to take note of here. Probability, this is the chance over the next 10 days of getting an inch. So it's increased right here where that frontal boundary stagnates next week. It's also increased along the south, and we need this. This is an area that has been going into drought and has been dry and is expected to stay drier here in the near term. So we're waiting on the next system to come through and relieve some of this. Week 2 looks something like this. And to be honest, the model's still a lot of uncertainty in week 2. I mean, look at the CPC's forecast for week 2. They've just kind of really opened up a lot of area to drier conditions. So they see one system exiting, another one entering, in the middle kind of going drier for a little bit. So will we see some more harvest windows in here? Sure. All right, temperature-wise again, let's come back to that. So we were expecting these colder temperatures this morning. This is Saturday morning. Big push at some colder air. This is now getting into Sunday. That gets all the way into the southeast. Temperatures in the 40s down here. Warm up happens west. That's that positive PNA ridge. Cool air exits. This might be the coolest morning here on Monday for the southeast. We get out there into Tuesday. Another reinforcing shot of some cooler air here. But then Wednesday into Thursday, that's when the warmth returns, opening up the warm sector for the next storm system. All right, we're almost there. Next 5 days, day 5 through 10, day 10 through 15. We've continued to see the model want to keep cooler conditions around this area for a while. We actually need the soil to cool down. We need moisture in here for fall application. So this is quite important. But overall, a warmer signal for the west continues to persist through the 21st of October. All right, last thing I want to tell you about is the same graphic, but I want to come back to another part of the world. You see, whenever the MJO spends a lot of time in phases 4 and 5, that has a major influence on the Brazilian monsoon. And I want to show you what that historically does. So this is a map looking at November to March precipitation anomalies given each phase of the MJO. Now remember, if the MJO is in phase 5, there's rising motion here, a lot of rain, and that tends to produce sinking motion in Brazil. See that? Now we don't have this. We have the MJO over here in phase 8 or phase 1. That means there's sinking motion, I'll put an X on it, there, and rising motion here, and rising motion here. Remember that from, I don't know, half hour ago when I started this? So the question is, if the MJO lives there, does it actually bring in better rainfall into this area? Now, if you're in Argentina, you want MJO phase 5 all day long because you tend to see it right on the edge. You tend to get better rainfall, but Brazil doesn't. So what do we have right now? Well, latest root zone soil moisture map. Argentina continues to struggle with drought. Massive flooding in southern Brazil, near normal root zone soil moisture for a big section of Brazil's growing area. The last holdout for drier conditions is like Bahia and Minas Gerais, that area. So as we play it forward in the forecast, newest update from the European model, we see halfway decent monsoonal rain here through the next 10 days, which means we're going to continue to see rapid planting progress. We'll get a new update on that later on this afternoon. and more flooding down here in parts of Paraná, Santa Catarina, and northern Rio Grande do Sul. Look down through Argentina, very little precipitation forecast. If you want to compare it all to average, see we're near normal across a big area here, extremely wet, southern Brazil, but Uruguay, Paraná River Basin, Argentina continue to be very dry. That is a story that has to be watched. There's 2 years worth of drought being added up here. So let's keep an eye on it together. Hey, I appreciate you all listening. I had a lot to say today about this forecast and nuances to it, and I'm glad I have an audience to kind of listen to what I have to say. So I appreciate it. You have a great weekend. We'll talk next week. Thanks.